Welcome you all on my YouTube channel Mathematics for All. This is Brijesh Kumar Jha from Department of Mathematics. So in this section we will see the solution of questions asked in IA1 April 2022. So check the question wise first. If you have not subscribed our channel, you can subscribe and you can comment on this video as well. So the question 1 was asked here. Consider the limit z tends to 0 z upon z bar whole square. So the question was given in the different section. First question is, what value does the limit approach as z approaches 0 along the real axis? Second is, what value does the limit approach as z approaches 0 along the imaginary axis? And on the basis of A and B, can we imply that the limit exists? So that we need to check. Fourth one is, what value does the limit approaches as z approaches 0 along the line y is equals to x? And what can you say about the limit of this? So collectively, this question is related to limit of a function. So one by one we will solve. So suppose in the dimension in the complex plane we have given here. So x-axis is the real axis and y-axis that we define as a imaginary axis. So question A is what value does the limit approaches as z approaches 0 along the real axis? So along the real axis, if you are considering, in that case y will be 0. So what we write here, z is equal to x plus iy and z bar will be x minus iy. So on the real axis that we know y should be the 0. So it means z tends to 0, it means it is similar to x tends to 0. So the limit z tends to 0, z upon z bar whole square that we write, since y is 0, so it is what, x upon x, that is 1, and so the limit you get here 1. So 1 square will be 1 here. So right answer is 1 for A. Now come to the part B. What value does the limit approach as z approaches 0 along the imaginary axis? So you know y-axis is the imaginary axis. So along y we are approaching to 0. So in that case x will be 0. So the imaginary axis on the imaginary axis x will be 0. So in this case z tends to 0 means what? Y tends to 0. So in that case, if you put here by putting x is equals to 0, what we get, z upon z bar will be iy upon minus of iy. So it is minus 1 square. So again it will be 1. So on the both way, along real axis or along imaginary axis, we get the same solution. Now the question 3 that was asked here, does the answer from A and B imply that limit exists? So that we have to explain. So this answer to this question, it may be in your own word, but in my word that we can see here. For the existence of this one, limit must exist along each and every path in which z tends to 0. And we have approaches here. What? Limit must be the same along each and every path. Hence, existence and uniqueness of the limit along the two paths along real axis, also imaginary axis, is not sufficient for existence of the limit. So those who have studied about the limit, we should understand that these two, the solution A and B, is not enough, not sufficient to make a decision that limit exists or not. So your answer should be what? The On the basis of A and B, we can't say the limit exists or not until we check the further uh, calculation. Now, okay, so conclusion, we have limit may or may not exist. So we are not able to say limit exists or not. Now come to the, we talk about the D. So what value does the limit approach as z approaches to 0 along the line y is equals to x? So this is important. That's why in the options C, in the question C, we are not able to say the limit exists or not. So as z tends to 0 along y is equals to x, so what we do here, we put y is equals to x in the function, and that's why x tends to 0 in the limit that we put here. So in the place of x plus iy, we have x plus ix, and in denominator x minus ix. So x you can take common, so it will be 1 plus I upon 1 minus I square, and by rationalizing that you can get here the value. Other way, here also you can conclude it is not equals to 1. So by simplifying, what we get here, it is minus 1. So that is really different from the previous section. What we have obtained the result in A and B, D is different. So that's why we can conclude the limit does not exist. So the last question, what can you say about the limit exist or not? So it is very simple that we can say the limit does not exist because it is minus 1 along the real axis and 1 along the y is equals to x. Real or imaginary both we can say. So only two we have to define the limit does not exist. So this is the solution of the question number 1 part A. So in next we will talk about the part B. Thank you for watching this video lecture. You can subscribe for upcoming videos, solution of the questions. Very soon, very quick, it will be uploaded. Once again, thank you for watching this video.